how do you find these asymptotes? Well, let's do an example. And I think you've already actually done a little bit of this on the homework already. So hopefully this is not, too crazy. So let's do this example. F of x is equal to x squared plus 4x minus 5 over x squared minus 5x plus 4. Kind of cool symmetry there. How do I find the asymptotes? Well, let me start by what we always do in this class, which is factoring. This is going to tell us not just the asymptotes, but this is going to give us a lot of information about the function. And this one's not too bad to factor. So if I look on top, I just need two numbers that multiply to -5 and add to 4. Well, that's going to be plus 5 and minus 4. Look on bottom. Now I need two numbers that multiply to 4 and add to -5. Well, that's going to be minus 4 and minus 1. So this is how it factors. And you might notice that the x minus 4's cancel, and they do. So this one actually simplifies down to x plus 5 and over x minus 1. Very nice. Okay, so what do we get? Well, anything on top here, like this x plus 5, this is going to give you an x-intercept. So the x-intercept here is x equals -5. And anything on bottom at this point is going to give you a vertical asymptote. So here we get a vertical asymptote at x equals 1. So we haven't found that there's a horizontal asymptote too we haven't found yet. But already we have a lot of the key information with regards to this problem. So let me go ahead and let's go back to Desmos and actually graph this one. So let me just erase this. And I'm going to get rid of these now. So this is x squared plus 4x minus 5 over x squared minus 5x plus 4. Okay. So I graph that. Let's just go back home and we'll zoom in a little bit here. Okay, so you can see those two things that we found. We found the x-intercept at -5, and you can see the vertical asymptote at, I forget where it was, at 1. Doesn't look like it's at 1. What did I do wrong?
Because it's supposed to be x plus 5 times x minus 1 on the top.
Oh yeah, I just majorly goofed up that up, didn't I? Always when I'm recording a video, that's when I screw up. No, but thank you, Shelby. Okay, so let's go back here. Let's factor this correctly now. So this should be x minus 1. So that's actually not what that's not what cancels. It's actually the x minus 1s that cancel. I knew something canceled. So what we're actually left with is an x minus 4 on the bottom. So our VA is at x equals 4. Great. Okay. So if you do it right, you can see that you get this VA at x equals 4. Great. So, okay, there's one other thing I want to mention though, and this is actually not in the graph at all, but this thing that we canceled. So remember, we canceled after I corrected it. We canceled the x minus 1. We actually get something there. We get a whole at x equals 1. So what's a whole? Well, it doesn't show up when you graph it on Desmos, but when you graph it by hand, I actually do want you to show this. So right here at x equals 1, you go down to the graph, there's a missing value there. Now, because of Desmos automatically smooths over it, so you don't see it in the graph, but when you graph it by hand, you should draw a big open circle there to indicate there's a hole. And if I actually call this something, so if I call this f of x, and I try to plug in f equals 1, you can see that it's undefined. So that hole kind of reflects that information. Okay, let's do the horizontal asymptote. And then they'll do another example. So for the horizontal asymptote and for the slant asymptote, so I think I'm actually, actually the easy way to do this is to go off the simplified version. But just to illustrate, I'm actually going to go off the original. So it makes it a little bit harder on myself, but sometimes you have to go off the original. So anyway, the key here is long division. Yes, so for those of you who are so sick of long division that you're about ready to go jump in a lake, I have bad news for you. There's more long division here. So the long division that we're going to do is, so the problem is x squared plus 4x minus 5 over x squared minus 5x plus 4. So I'm actually going to do, this long division. And so I'm going to take the bottom of my fraction into the top of my fraction. So the good news is a lot of times you don't even really have to do long division. But let me go ahead and do it here. So how would you actually do the long division? We've never done it with an x squared before. Well, x squared, so let's just try it. X squared goes into x squared. Well, this goes in once, right? So if I multiply this, well, I guess get the same thing again, right? 1 times x squared is x squared. 1 times negative 5x is negative 5x. 1 times 4 is 4. Draw a line, change the sign, and change the sign there. And what I get is a remainder of, well, these cancel. I get 9x minus 9. So the answer here is, find remainder 9x minus 9. So basically your horizontal or slant asymptote is right here. That's your answer. You don't even care about the remainder so much. Y equals 1, that is your, in this case, it's a horizontal asymptote. And it's horizontal because y equals 1 is just a horizontal line. And you can actually see that in Desmos. So if I go back to Desmos, if I type in y equals 1, it creates this horizontal line. That's the, is the HA. So the key is long division. So in some sense, you don't really care about the remainder. Let me just real quick explain though why this works. Because this might at least, and if this doesn't make sense, no worries, but this might click in some people's heads. a long time ago, I think it was Matt made the point that in Khan Academy, when they do the long division, they write it in kind of a funny way. So let me actually go ahead and do that here. So I'm going to scroll down a little bit. And how they would write this is x squared plus 4x minus 5. So what's here is equal to, well, it's equal to the, divided by, I forgot this last time too. Okay, so this whole rational expression is equal to, well, it's equal to 1 when you divide that, plus 9x minus 9 over x squared plus 4x minus 5. Well, think about what happens when x gets really big. This rational expression, which is equal to this, when x is really big, you're going to get basically 1 plus, well, this is a linear function. This is degree 1 over something that's degree 2. Degree 2 is way bigger than degree 1. So since the bottom of this fraction is bigger than the top, this ends up approaching 0. And so when x is really big, that's why the function just looks like a 1. And that's what Desmos basically looks like. So as you, especially if you zoom out here, if I zoom out, you can see that basically the function just follows that 1 almost perfectly. That is why long division works, because you basically, by doing the long division, you isolate the important part. Okay. Let me do, okay, so that's basically everything. That's the x-intercepts, the vertical asymptotes, the horizontal asymptotes, and the holes. Let me do another example, maybe do an example with a slant asymptote. Let's start a new page. So let's do, okay, this one is, this will be good to do. 2x cubed minus x squared minus 18x plus 9 over x squared plus 2x minus 3. Okay. What are we doing in this problem? So I want to find all intercepts, holes, and asymptotes. Asymptotes. Okay. So what you should be doing at home now is see if you can guess what I'm going to do next at every step. But this is what I want to do. I want to find all the intercepts, holes, and asymptotes. So let's start by factoring this. We're going to factor this. And luckily, so even though that's a cubic on top, luckily I believe that's going to be a grouping. It's always good to think about if it's grouping instead of launching right into PQ. So if I group the top here, I think a plus and minus maybe. If I group the top, what that ends up being is I'm going to factor x squared out of the first two. We both put 2x minus 1. And a minus 9 out of the second two. And then we'd be left with 2x minus 1. Now on bottom, I have, this is going to be a simple one. So I see two numbers that multiply to -3, add to 2. That's going to be plus 3 and minus 1. So 3 and 1, multiply -3, add to 2. Okay. Going a little bit slower now. I was so excited about telling you about intercepts, or sorry, asymptotes, that rushed through the last one and screwed up the factoring, but it's good to go slow. Okay, so we're not quite done factoring, so we need to pull up the 2x minus 1, and we're left with x squared minus 9, x plus 3, x minus 1, and we're still not done because x squared minus 9 factors x plus 3, x minus 3. So, now that we factored it, you'll notice something cancels. The x plus 3 cancels. So this actually simplifies to 2x minus 1 over x minus 3 over x minus 1. So that is nice when it simplifies. The one thing you have to remember when that cancels is you get a hole there. We're going to get a hole at, well, the solution that corresponds with x plus 3 is minus 3. We get a hole at x equals minus 3. Okay, but this is great because this now immediately tells us the x-intercepts. We get x-intercepts at, this one is going to be a 1/2, and this other one is going to be a 3. Those are the x-intercepts, and we get a vertical asymptote, a VA at 1. Okay, great. The next thing to do is figure out the slant or horizontal asymptote. Now in this case, this one's actually going to have a slant asymptote. So the original problem was 2x cubed minus x squared minus 18x plus 9 over x squared plus 2x minus 3. And so to find the horizontal or the slant asymptote, I just set up a long division. Like this. And even though I have, again, a quadratic as what I'm dividing by, the long division actually proceeds kind of in the same way. I'm going to ask myself, okay, how many times does x squared go into 2x cubed? Well, it goes in twice 2x, right? 2x cubed divided by x squared is 2x. So if I multiply, I'm going to get 2x cubed. 2x times 2x is 4x squared. 2x times -3 is minus 6x. Got my x right there. I'm going to draw a line, change the sign on everything. And I get 0. I get negative 5x squared. I get negative 12. Turn black for some reason. Sometimes I like to do that, but that's fine. So, but I'm not quite done yet. So now I need to keep going. X goes into negative 5x squared. It just goes in negative 5 times. And basically at this point I can kind of stop because you know, once I cancel this negative 5x squared, once these cancel, I'm just going to be left with terms that are too small for x squared to go into. So everything that's left is a remainder. So here is actually my answer. Y is equal to 2x minus 5. And just because this is a slanted line, this is a slant asymptote. So there's really no difference between slant and horizontal asymptotes. It's just, they're called different things depending on if it's a line or whether it's horizontal or not. Okay, so if I go back to this slide, I now have my my slant asymptote at y is equal to what was that again? 2x minus 5. That's going to be part of my answer here. And the last thing I'm looking for is the y-intercepts. They may shout out, how do you find a y-intercepts? How do you find a y-intercepts?
Plugging in the x values.
Yeah, that's how you find y values, right? And for a y-intercept, it's just x equals 0. So if I go back to my original equation, and if I plug in x equals 0, that's going to give me my y-intercept. So it's going to be 0, 0, 0, 0, 9 over 0, 0, 0, negative 3. So my final thing here would be a y int at it's going to be 9 over negative 3, which is negative 3. So that's all the information I'm going to be looking for. Now we didn't get to actually graphing it, but this is the information we'll need to graph it. So I think this is a good place to stop. I'm going to stop the video.